Although I'm not going to do this in the book, we see that the book shows how you can create a node class for a linked list. So set up a class with everything being private. All the data members are private. So in this case, it's just a node storing a single int and a pointer to the next node in the list. We have a type def just like before with structs. So you could take basically all of this code and put it into here instead of the struct. So that's where you would replace the struct with a class like this. Of course, if you want to use templates, you'd have to change things around. Maybe you wouldn't even want to call it int node, just call it node and things like that. So, and you would use, if you templatize this, you wouldn't say int, you would say whatever name you use, t for data, and then you would have a t here, and a whole bunch of other places. And essentially this would work. Of course, once you make the link data member private, you cannot access it right away. I mean, you cannot access it easily. You have to go through the set and get methods. Okay, so, but it's all doable. So I would leave that for you to do. Take this class and put that in some of the previous versions of the code that we set up for the linked list class. Use a class for the node instead of a struct, with everything private and methods to get at these things. Okay, so it's always this is definitely a good exercise to do. So I would say try it out. I'm not going to show that in the video because it's pretty straightforward. Okay, so for this class, once we set up this class, notice that all member functions are inline. This is simple enough that probably that's okay to do. That is, all of these methods have function bodies right there, because notice they're all really simple. They're small and simple enough that making them inline is pretty reasonable. Of course, if I ask you to make a .cpp file with all of the function bodies, you want to do that even if it's reasonable enough to put it into .h file, make it inline. Notice also the two-parameter constructor in this case. It allows the creation of nodes with specific data values and a specified link member. That's a good thing to do. We didn't do that because we use structs, and we didn't try to use this kind of a structure. That is, when you have a constructor, you pass in arguments that are of the type of the same type as the private data members, and use the constructor to initialize your node. So for example, in the previous class, you would pass in an int and a pointer. Okay, so it's definitely much better, much more object-oriented approach. Okay, so to create the first node, here's what you want to do, and I've seen people do this a lot. That is, declare a pointer and right away use the new, just because we have a pointer. No, you don't need to do that. You can. I would say whenever you have a pointer, always initialize it to null, even if the very next step is going to be setting it equal to some dynamically allocated new node. Always use pointer variables, always set pointer variables to null. Even if you have a new node created for it in the very next step. So for linked lists, that's typically what you want to do. You want to set the head equals to a new int node. Now we did this slightly differently. First time around we used a struct, and the structs will work too for this. Okay, then we can set the data member. If you're using a class with member functions like set data and set link, you can call these, or you can, if you're using structs as we did in our videos, we can just access those data members directly because we made them public. Okay, so if you're setting up a new node in a linked list, this is what the picture you want to mind. You want to have head, well actually this is after inserting a second thing. So initially head should just point to one thing, and it should have a null for its link data member. If you add a second thing, yeah, you should see something like this. If you add a third, you have to do it in steps. You have to say head is initially pointing to the 15. You create a new node, and that's pointed to by, let's say, a temporary value, temporary pointer. Then you have to do just one single thing, which is to say that have head point to the same, or head gets assigned the value of whatever this was, temp, let's say. So head is equal to temp, we'll have head point to the same thing that temp points to. And that's how we did things in our code. When we insert, we create, so we set up this node pointer, set it equal to null. That's what you want to do. Create a new node, set the data members, and then set head equals temp. So this is what happens when you set head equals temp. Let's say temp is pointing to here. Head now points to the same thing that temp points to. And then the actual variable temp, you don't need to use it anymore. So we throw away that pointer. You don't need that pointer pointing to this new node because head is pointing to it. So one of the things that you want to keep in mind is that when you have a linked list, you only have a name for a pointer to the first thing in the list. None of these other things really are addressed by name. Actually, even this is not really addressed by name. It's addressed by dereferencing a pointer. So we have a pointer to this object, we dereference it, and that's the only way to access this node. We don't even have a name for it directly. And that's how linked lists work. You can have a million things, no names for anything except the pointer to the first thing in the list. You can lose nodes very easily. For example, if you set head is equal to new int node and you set the data and you set on, let's say you had initially head is pointing to this node with the 15 in it, which points to the node with the 3 in it. If you say head is equal to new int node, then you create a new node, and in the next or the link data member might be set to null, which means you've lost these old nodes, the 15 and the 3 you've lost. Instead of doing that, you want to do it in 2 steps. You want to create this new node using a temp pointer and then set head is equal to temp. Of course, when you create this new node with a temp pointer, you want to have the link data member be assigned the same value as head. Okay, so that's how you create this link from here to here. Oops. From this new node to the existing value of head. So let's take a look at that. Here's where we did it. We created a new node. When we said temp arrow link is equal to head. All right, and this looks kind of, it takes a little bit of getting used to. Breaking this down in 2 steps may not be completely necessary, but it makes everything really clear. Create a new node, set the link data member to have the same value as head, that is, it points to the first thing, the old first thing in the list, and then we set head is equal to temp. So that's here. We create a new node. The link points to the old first node in the list, and then after that we set head is equal to temp, which says head is now going to point to this thing, and now we have a new first node in the list. So you don't want to do it this way. You can very easily, you don't want to say head is equal to new int node. Actually, there is a way to do this, but you want to be careful about how you do it, because you could end up in this problem. You could run into this pitfall. That is, you end up losing all the nodes in the list. You don't want to do that. And I've seen this happens every year with the first linked list program. You end up losing nodes. You end up doing all sorts of things that you probably shouldn't do. So now, so far we haven't talked about how do you add things to the middle of the list. So you would want to do that. Let's say if you're keeping a list of ints in sorted order, you wouldn't want to always add it to the front of the list or the head of the list. You would want to add it in order. So let's say you have 2, 3, 9, and 18. You have a new node with the 5 in it. This has to go between the 3 and the 9. So you need a pointer to here. How can you get a pointer to here? Do you change head? No, you don't want to change head, because that's another pitfall. If you say head is equal to head arrow link, you'll have head pointing to the next thing, and now there's nothing pointing to the old first node in the list, and so now that node is lost. Okay, so what you want to do is, if you're going to insert into the middle of the list, you have to have one pointer to keep track of the new node that you just create, another pointer to go up and down this list. And actually usually it's just going down the list. So how do you do that? You set up a new variable, temp2, let's say, assign it the same value as head so that it points to the same thing as head, and then say temp2 is equal to, in this case they actually use the name after me, and then you can use after me is equal to after me arrow link, which takes you to the next node. If you do that again, after me equals after me arrow link, you get to the second node, and so on. So you can go down the list, find the node before the one that you want to insert between. So when you get a pointer to here, and here's the rewiring that you want to do. You want to have this new node point to the next node in the list, that is point to the 9, and then once you've done that, you want to have this link point to this new node, and there you've spliced in this new node. So now after you're done, you don't have to keep this around. You don't have to have this after me pointer around. You have the head, pointing to this first node, pointing to the second node. This will be rewired to point to here, and then the link data member of this new node will be pointing to here, and so on. So you've just spliced in a new node. Okay, so after me will have to be set so that the link data member points to this new node, and you can do it all in one step if you want. And the book, that's the way the book does it here. Instead of doing it, I would say initially just break it down into steps. Create a new node, set the link data member to point to this thing, and then have this link point to this new node, and so on. And the book does it in one big step. Now removing, you have to do the same kind of rewiring. So let's say you have found the thing that you want to discard. You want to discard this. Now that might be the result of a search, and so on. But whatever the case is, let's say you want to discard this. What you want to end up with is not the thing that you want to discard, but a pointer to the thing before it. Because if you have a pointer to this thing, the one before it, then you can say, let's say it's called before. You can say before arrow link is the thing that you want to discard. Now, how does that help you? Because you want to, when you're all done, what you want is, instead of having this link before arrow link point to the thing you want to discard, you want to have that before arrow link, that's this thing, point to before arrow link. That is, you want to have this thing go around the thing that you want to discard and point to here. And now you can delete this. Delete as in deallocating the memory for this object. So once you've done this wiring around the thing that you want to discard, it doesn't matter what you do with this because it's outside the linked list now. You've sort of wired around it, and now you can delete it.